Hi guys, this is O-level chemistry, paper 11, November 2019, question 1. The concentration of aqueous sodium carbonate can be found by reaction with hydrochloric acid of known concentration. The indicator methyl orange is used. So this statement tells us that we are going to be using the technique of titration to obtain the concentration of aqueous sodium carbonate. Which items of equipment are needed? Okay. Burette, yes, it is needed. Measuring cylinder, no, because in titration, we do not measure approximate volumes, we measure accurate volume. So measuring cylinder becomes unnecessary. Gas syringe, there is no gas involved in this procedure. Okay. Again, burette, measuring cylinder is a no. And thermometer. Thermometer is not required because there is no change of temperature taking place during the reaction that needs to be measured. Next, we have got a burette, yes, a pipette, yes, and a conical flask, yes. So a burette will be used to allow HCl to flow into the conical flask. The pipette will be used to take a solution of unknown concentration sodium carbonate into the conical flask, and the conical flask will be the apparatus in which the neutralization reaction will occur between the sodium carbonate and HCl along with the methyl orange indicator. So all three pieces of apparatus here are correct. And next, again, we have got burette, pipette, and stopwatch. Stopwatch is used to measure time, the time it takes for a particular quantity of a substance to be collected or decrease in mass or anything. Nothing like that happens in a titration, so stopwatch is not required. So the correct option for this question is option C. Question 2. Which process is involved in all of the following? Obtaining copper 2 sulfate crystals from aqueous copper 2 sulfate. Okay, we need to evaporate the water and obtain the crystals. Obtaining ethanol from fermentation of glucose. Obtaining ethanol from fermentation of glucose. Okay, so we need to distill the contents. We need to evaporate the ethanol and collect it as a pure sample. And obtaining nitrogen from liquid air. So fractional distillation would take place in which different fractions would be collected at different temperatures. So they will have to be evaporated. So crystallization is required only in one. Evaporation is required in one, two, and three, all three of them, because in each of them we need to evaporate something in order to obtain it as either in the fractional distillation or in distillation or in crystallization, because in crystallization we evaporate away the water. Okay, filtration. Filtration is not required here in either of these three processes, and fractional distillation is only required in three. So the question asks us which process involved in all of the following. So the correct answer for this question is option B. Question 3. In which reaction is a white precipitate present when the reaction is complete? Okay. Excess barium nitrate is added to aqueous sodium chloride. There will be no precipitate. Excess aqueous sodium hydroxide is added to aqueous ammonium chloride. There would be no precipitate. Excess aqueous sodium hydroxide is added to aqueous iron 2 sulfate. There would be a precipitate, but its color would be green, not white. Excess hydrochloric acid is added to aqueous silver nitrate. White precipitate of silver chloride will be formed. So this is where we get the white precipitate, making option D the correct option for this question. Question 4. Which three elements exist as diatomic molecules at room temperature? Okay, hydrogen, diatomic, oxygen, diatomic, helium, monoatomic. So helium causes this answer to be incorrect. Next, nitrogen, diatomic, chlorine, diatomic, neon, monoatomic. So this becomes incorrect as well. Next, nitrogen, diatomic, oxygen, diatomic, fluorine, diatomic. So all three are diatomic in this option. And the last one, oxygen is diatomic, chlorine is diatomic, and helium is monoatomic. So this is incorrect. Therefore, the correct answer for this question is option C. Question 5. Sulfur dioxide is a gas that is prepared by heating sodium sulfide with hydrochloric acid. It is an acidic gas. Sulfur dioxide is more dense than air. Which set of apparatus is suitable for preparing and collecting a dry sample of sulfur dioxide? Okay, so we've got an acidic gas being produced. So in A, we have a gas being produced and it is passing through calcium oxide. Okay, this makes it incorrect because calcium oxide is basic in nature and it would react with the acidic gas forming salt. So because of this basic calcium oxide, setup A is incorrect. In B, we've got the sulfur dioxide gas passing through concentrated sulfuric acid and then it is being collected in a downward delivery system. This is all correct, but the issue here is look at the round bottom flask. At the top of it, we have a funnel placed for addition of a liquid where we need a burette. So because of this funnel, this setup is also incorrect. Option C, we've got a burette, we've got a round bottom flask, we've got concentrated sulfuric acid, we've got the delivery tube going inside the concentrated sulfuric acid so that it is bubbled. Then we've got dry SO2 being collected in a downward delivery system because it is more dense than air. So nothing seems wrong here. So this should be the correct answer. But let's look at option D. We've got the burette, we've got the round bottom flask, we've got concentrated sulfuric acid, but the problem here is that they are collecting the gas in a gas jar using an upward delivery method. SO2 is more dense than air. It will not remain in the gas jar, it will come out. So that makes apparatus setup in D incorrect. So the correct option for this question is option C. Question 6. Which diagram best represents the structure of solid metal? So in solid metal, we've got uh, positive ions present in a sea of delocalized electrons. In A, we've got positive and negative ions. The presence of negative ions makes this structure incorrect. In B, we've got delocalized negative charges, which are electrons, and in between the positively charged nuclei. So this is correct. In C, we've got a setup in which the positive ions and the negative ions are arranged in an array. This is not delocalized electrons. This does not represent delocalized electrons, so this makes it wrong. And in D, we've got all positive charges together and all negative charges outside of the positive. They are not delocalized between them, so this makes it wrong. So the correct option for this question is option B. Question 7. Hydrogen sulfide burns in excess oxygen according to the equation shown. 48 dm cube of hydrogen sulfide is burned. Which volume of sulfur dioxide will be formed at room temperature and pressure? Okay, so according to this equation, the molar ratio of hydrogen sulfide is to sulfur dioxide is 2 is to 2, which is the same as 1 is to 1. So if the molar ratios are equal and we have 48 dm cube of H2S burning, this should produce 48 dm cube of sulfur dioxide. So this makes option C the correct option for this question. Question 8. Which row correctly identifies the different formulae of ethene and its homologous series? Ethene is an alkene. Alkene has an empirical formula. So the general formula is CnH2n. So if you remove the N, the empirical formula would become CH2. So CH2 is the empirical formula. Options A and B are correct. C and D have been eliminated. Moving on. C2H4. C2 H4 is the molecular formula of ethene. So option B has been eliminated, option A remains. And the last one, CnH2n is the general formula of the alkene homologous series. So all three are correct in A, making option A the correct option for this question. Question 9. Ammonia is manufactured from nitrogen and hydrogen by the Haber's process. What is the percentage yield when 60 kg of ammonia is produced from 60 kg of hydrogen? Okay, so according to this equation, 3 moles of H2 produces 2 moles of NH3. So the MR of hydrogen would be 2, the MR of nitrogen would be 17. And since we've got 3 moles of hydrogen and 2 moles of nitrogen, we multiply the MRs by the molar ratios. So we end up with 6 kg of hydrogen producing 34 kg of ammonia. And the question says we have 60 kg of hydrogen. So how much ammonia would be produced? So this would give us 60 divided by 6 multiplied by 34, giving us a value of 340 kg being produced. However, in the question it says that 60 kg of ammonia is produced. So out of 340, 60 kg of ammonia is produced. That means 60 upon 340 is the ratio of production of ammonia. And if you multiply this value by 100, we would get the percentage yield. So the percentage yield is worked out to be 17.65%. So this makes option B the correct option for this question. Question 10. What is the ratio of the number of molecules in 71 grams of gaseous chlorine to the number of moles in 2 grams of gaseous hydrogen? So chlorine is to hydrogen, and we want to find out the ratio of the number of molecules. So number of molecules can also be represented by number of moles. So in the case of chlorine, we divide 71 by 35.5 mass upon AR, and in hydrogen we divide 2 by 1, the AR of hydrogen. This gives us a value of 2 is to 2 for chlorine and hydrogen, which is the same as the ratio 1 is to 1. This makes option A the correct option for this question.